Hello, so today we're going to talk about how to graph linear equations and linear inequalities. So linear equation, linear inequality is going to look like in this particular form right here, y equals negative 2/3 x plus 4. This is what we call our slope-intercept form, where it's in the form of y equals mx plus b, where the m, the number in front of the x, represents our slope, and the b value is the number that's at the end, that constant. That's going to represent our, that'll represent our y-intercept for the particular equation. So the key is we want to make sure that we plot the points correctly and make the equation from there. So for this particular equation, our m value is the negative 2/3 right there, and our b value is the positive 4. And we're going to use those to make our plots. I apologize for the video kind of jumping around a little bit. The pen option on my tablet wasn't really working out too. There we go, that's working out fine now. So, what we do is we always want to plot the y-intercept first. So we plot that 4 on the y-axis. Goes right there. The negative 2/3 tells us our slope, where we're going to go down 2 and to the right 3. So we go down 2 and to the right 3. You also could have gone the opposite direction because the negative doesn't have to be at the top or in the bottom. So if you thought of it as a 2 over negative 3, then we would go up 2 to the left 3. Either case is perfectly fine. You don't need to draw all 3 points. We only really need 2 points to create our line. And we just connect our dots to draw a line for this particular equation. Good practice is also to label the equation on your graph. Y equals 2/3 x. Negative 2/3 x plus 4. I'm not going to require you to label each one of the lines, but if you do have graphs with multiple equations, it's definitely a very good idea to label each particular line. Now the other possibility for a linear equation is when it's in standard form. This is we have 6x minus 5y equals negative 30. One option behind this is to solve this out into linear slope-intercept form and get y by itself. Not really necessary. When it's in standard form, you can always solve for the x and y intercepts by saying the x expression, 6x, equal to the constant, negative 30, and the y expression, negative 5y, equal to the constant, negative 30. By solving out both these equations, you will find where we cross the x-axis, which will be at negative 5, and then the y-axis, which is positive 6. Again, you are more than welcome to rewrite this into y equals mx plus b form, which you would have to subtract 6x first and then divide by the negative 5. That's how you would have to solve an equation like that. So again, up to you. I find it easier, though, to work in slope-intercept form. Now, if you notice with this next graph, we do not have any x expressions. All we have is just simply y equals 5. This is the case of our horizontal line. What we want to do is we want to plot the 5 on the y-axis, and we just simply draw a horizontal line through that point. That's all it is. Y equals whatever the number is, you just plot the point on the y-axis, whatever number it happens to be, and draw a horizontal line through it. Conversely, if we have just x equals a number, it's the same idea, only we'll plot it on the x-axis, so negative 2, and then we'll draw a vertical line through that point. So that's what we're doing in those two particular special equations. Y equals a number, plot on the y-axis, horizontal line through. X equals a number, plot on the x-axis, vertical line through it. Now, with the inequalities, graphing these is the exact same process as graphing the equations. There will be just 2 differences behind this. The first thing we'll do, though, because it's in y equals mx plus b form, we'll plot our y-intercept. And our slope is negative 2/5, so we go down 2 and then to the right 5. Now, the first of the 2 differences is that when we connect the points, we will have a dashed or a solid line. If it's just less than or just greater than, we'll use a dashed line to connect the points. The reason why is because technically less than, we can't include the values on the line, because the values on the line represents points. And it would not be true if it was like 4 is less than 4 situation. So that's why we use a dotted line to represent here's where the shape is going to be, but we can't include these particular points that fall on this line. Now, we also need to include a shaded region, where we're either above this particular line or below the line. We'll find that if it's less than, and it has to be in this particular form right here, slope-intercept form, if it's less than, we'll be below the line. So in this particular case, our region has to be everywhere below the line. If it was greater than, we'd have to be above the line. If you're not sure which direction you can go, simply plug in a point. Generally, the origin point is the best point to plug in. So we plug in 0 for y and 0 for x. We get 0 is less than 4. Since that's true, we need to make sure the shaded region is including the origin points. Had it been false, where it would have been greater than instead, then we'd have to be not including it. That's what we know it's above or below the line. Again, you don't have to plug in the point when it's in slope-intercept form. It's pretty easy, above or below based off the inequality sign. When it's in standard form, you need to be a little more careful, though. Again, first off, we still find the points. So 2x equals 12, negative 3y equals 12. So x is 6, and y is negative 4. So we go to 6 on the x-axis, and we go to negative 4 on the y-axis. Now for this one, because it's greater than or equal to, it has the equal to components, we will use a solid line to connect the 2 points. Now, we need to make sure we're careful. With the greater than or less than idea, doesn't necessarily always work correctly when it's in standard form. Simply because if we were to rewrite in slope-intercept form, we need to recognize we'd have to divide by negative 3, which would flip the inequality sign around. Again, your best bet for something like this is using the origin point, 0, 0. We plug in 0 for x and 0 for y. We get 0 greater than or equal to 12, which is false. So when we're false, we don't shade with the origin, which since that's above the line, we have to go below the line. With inequalities, this is the one time where solving for slope-intercept form might be a little bit easier, because when we subtract the 2x over, we get negative 3y greater than or equal to negative 2x plus 12, and we divide by the negative 3, we notice the inequality sign has to flip 2/3 x minus 4. And we'll get the same exact equation. We'll find still winds up to negative 4. We go up to right 3, up to right 3. So it's still the same points, but now it's more obvious on why we're below the line here. So your call with whether you want to plug in a point or rewrite into slope-intercept form to make sure you do your shaded region properly. Again, that's totally up to you. Alright, so that's all we have for today for graphing these equations. So I'll see you next time with our next concept.